Hey, Algebra 2 Honors, working on another video for you here, this time still in polynomial operations. Was doing a problem and realized that it's going to take polynomial long division. And I thought, well, that'd be a great opportunity for us to really get down and look at polynomial long division as a reminder of how to do it. So I'm going to share my screen with you, and we're going to look at the example from the quiz that I was using. So my first thought was, I think it's going to be a combined like terms and factor problem, but that didn't happen because I look at it and there really isn't a whole lot of like terms. So I'm looking at the numerator. It's an addition problem, so I'm going to rewrite this thing and I'm going to try and find my highest degree term. And since there's a plus in front of the polynomial, I don't have to worry about changing any of the signs. But if this would have been a minus sign, then we would have had to push the negative through before we combine our like terms. So I'm going to rewrite this. The highest degree term is 3m to the fifth. And then we have the 7m, the negative 7m to the fourth, and the negative 12m to the fourth. So that would be negative 19m to the fourth. And then I have my 15m cubed. And I also have my minus 7m cubed. So that's going to be a positive 8m cubed. And then last but not least, I have my negative 12m squared. And it doesn't have any like terms, so I'm just going to copy that down. And all of this is being divided by m minus 6. Okay, so what we can do from this point is take, since I would try and factor this if I could, and basically the only thing I can do is take out a GCF, I'm going to rewrite this as a polynomial long division question, and hopefully I can get a more simplified answer. So don't forget, when you write out a polynomial long division question, if there's any degree that's missing, you also have to include that degree in your problem as you're writing it out. So I have m minus 6 divided by 3m to the fifth minus 19m to the fourth. My kids are going nuts upstairs. It's about lunchtime. Plus 8m cubed minus 12m squared. So the language that I used when we went over how to do this was try to figure out what can you multiply the leading term in your divisor by to make it match the dividend number here. So m times what gets me 3m to the fifth. So I need to use a 3m to the fourth, and I'm going to list that over top of the negative 19 so that I'm pushing down two terms at a time because I'm going to distribute that down. I'm going to distribute that to this and rewrite. So it's 3m to the fifth minus 18m to the fourth. And remember, we know that this is a subtraction problem in between here, and one of the things that I would always do so we didn't mess that up is actually write a minus sign in between. So the leading degree term cancels out, and that's our goal pretty much every time as we work our way through this problem. This will turn into plus a positive, so I end up with a negative 1m to the fourth. And I'm going to drop down the plus 8m cubed because I'm dividing by a binomial, so I want to continue to have a binomial here in my math. So now I need to make this multiply m by something to get negative 1m to the fourth. So I need a negative 1 and I need m cubed, and I'm going to distribute that down through here too, like I did the other one. So I'll have negative 1m to the fourth, and this will turn into a positive 6m cubed. And again, I'm going to put a subtraction sign in between here so we can see how that's going to cancel off the leading degree term. And now we're looking at 8 minus 6, which is 2m cubed. I'm going to bring down the negative 12m squared. Okay, so now what I'm going to be looking to do, same thing. What can I multiply m by to get 2m cubed? And so I need a 2 and I need an m squared. So I'm going to put a plus 2m squared up here, multiply the 2m squared through the m minus 6 and down, and I'll have 2m cubed minus 12m squared. And it looks good to me that we're going to have 0 remainder. So the leading degree term cancels out. This turns into plus a positive, and 0 would be my remainder. So the answer to this question, I mean, the original question looked like this, right? But the answer to this question now is really the quotient here that we get after we divided it by m minus 6. So hopefully that reviews how to do polynomial long division. If you need another example, please don't hesitate to email me, and I can walk through how we did the long division again with you independently. See you later.